All right. So why Java? What is does it anybody done the reading and want to say like what is Java in terms of like why is it cool? Why is it useful? Why are we learning it? It's because it's better than C sharp, right? I'm just kidding. So here's the thing with what you've learned so far. You've learned Python and JavaScript, right? Python and JavaScript do a lot for you behind the scenes. They do a lot of hand holding. There's a lot of stuff that it does sort of magically, right? So by learning Java, you are learning more about how your computer actually functions and how it stores data, how it operates under the hood. Okay, so with with Python, let me share my screen. Let me get my IDE open. Share my screen. Okay, cool. So again, just to show you what I've got, this is the repository you all will all have access to. I'm going to write everything in this directory called code. Okay, so if you want to follow along, if you've cloned my repository, I'm going to be writing code in here. So inside here, inside day one, I'm going to go into hello world and I'm going to make a new file and we'll do, I'm partial to Python, so I'm going to do Python. So if I want to declare a variable that's going to store a name, how do I do that? I know it's been a while since you've done Python.
You just name it and give it a value.
Exactly. Yeah. So if I want to say, I can just say name equals Tyler, right? And that's it. And if I want to run this, or if I want to actually have it print to the screen, what do I do?
Print name.
Mm-hmm. Yep. Print name. Oops. Cancel. And now if I want to run this, I just make sure I'm in the right terminal. And it's just Python, the name of the file. And why didn't it print? That's weird. I'm going to use a different.
You did hello.c.
Did I do hello.c? That would be wrong. That would be
Yeah.
why. Okay. So try that with the right file, Python hello.py. There we go. Cool. So Python behind the scenes is looking at what we assign to the variable name. It sees that it's a string, right? So Python will keep track of the fact that, okay, right now, name, the variable, holds a string as a type, right? If I want to come down here and say name equals 42, is this okay? It's perfectly fine, right? Because Python, the Python interpreter is keeping track of the variables and what they hold for us. Okay. This, though, is really sloppy code, right? If I'm making a variable called name and I start by storing a string in it, and then I change my mind and put 42 in there, this is not the most readable, but not the best practice for writing code. John, what's up?
Over the weekend, I was actually trying to watch some quick YouTube videos about like Java and the differences between a high level and a low level language.
Mm-hmm.
Um, I can't remember exactly how it went, but if you were to do name equals one, right? Just like you typed out the three letters, O N E. and then you did name equals one, the character one, the number one. Are those equal to each other? Is that how? Is it high, like a high level language like that?
So I make the name equal one, like the string one, and then name equal one, the number one, like this. Is that what you mean?
Yeah, I don't know. The YouTube video, it was just a YouTube short. I don't know if I understood it, but would those two be equal to each other if you were to like check if they were true?
Well, that's not going to work. So name one, and you're asking, will this be equal to this?
Yeah, essentially. I don't know. I just thought it was like curious when I saw it.
This should not be equal. Let's see. Unless you know something I don't. Let's see. Yeah, they're not equal.
Okay. I didn't think that they would be. I just thought it was such a fascinating like thing that I came across over the weekend.
Okay. Okay. I think I might know what you mean, but we'll get to that. I'm going to talk about that in a second. Okay. So when I write Python code, the way the computer is looking at it is it's like an interpreter. Well, the program that runs my Python code is called the Python interpreter, right? So what the interpreter does is looks at my code, goes line by line, and interprets it, and it prints it. If there's no errors, it just runs, right? The way now Java, on the other hand, is what's called a compiled language. So with a compiled language, we have a compiler. So it's kind of like, I look at it as the difference between it, like say you have an interpreter in a courtroom or at the United Nations or whatever, and as somebody's speaking, they are interpreting what they're saying from one language to another, right? So they're doing it on the fly as it's happening. They're interpreting what the person says from, say, English to Spanish, right? And that's Python, that's JavaScript, that's any sort of interpreted language. With a compiled language, it's like taking Don Quixote, which is written in Spanish, and translating the whole thing into English, and then the compiler or the interpreter that it translates the book gives you the finished product. They give you Don Quixote in English. So that's what the difference is between an interpreted versus a compiled language. So if I run a compiled language, if I write a compiled language, it's going to have an intermediate step. Okay, so we're going to first compile the code that's written in more English-like language, and it's going to translate it into something that the computer understands. Okay, does that make sense to everyone? Okay, so the cool thing about Java is if I write code on a different computer, which I'm about to do. Let me stop sharing here. Bear with me. This is the first time I've tried this, so let me share this screen. Oh boy. Oh my gosh. Okay. You guys see my screen? Yes, you do. Okay, cool. So I'm going to now I'm on Linux. So this is my Linux machine, just to show you, prove to you that I'm not on Windows. You guys still hear me? Still see me? Okay, cool. So this is the same repository that's open on my Linux machine. Okay, so I'm going to come into the code directory in Hello World, and I'm going to write the Hello World program in the C programming language. Okay, so I'm not going to teach you C, don't freak out, but I'm just going to show you an example of a compiled language, because C is the only other compiled language I know. So if I want to write Hello World, okay, can't forget semicolons. And it's going to probably be mad at me if I don't say int and return 0. Okay. So notice the difference between this and Python, right? For Python, it's print hello world. For a language like C or Java, there's a lot more boilerplate, a lot more stuff we need to include, right? So notice that we have to have a main function. Okay, I can't just say printf hello world. I have to have this intermediate, this function that the compiler knows that this is what it calls. This is where it's going to start. So we have to have as our entry point this int main function. Okay, so when I compile this, make sure I'm in the right place. CD code, CD day 1, and CD, what did I call it? Hello. Okay, so I've got my hello.c here. In order to compile C code, I need to use the C compiler, which I have installed on my machine. So I'm going to say it's GCC, and then if I just give the name of the program, no news is good news. If I don't see any errors, then it worked. And if I look at, oops, if I look at my file structure, and you can see it here as well, when I compiled the code, it developed this a.out. Okay, and that's the code that is the, if I try to look at it, it's not going to let me look at it because it's bytecode. This is basically what the computer understands. The computer just understands assembly, zeros and ones, that kind of thing, right? So it's, the compiler has taken the code that I've written in something that kind of looks like English or is more English-like, and translates the whole thing into this file that the computer can then run. So this is what's known as an executable. So if I say ./a.out, I get hello world. And I forgot my new line. Let's make it a little prettier. So if I make changes to my code, and if I run a.out, why doesn't it work? Why I put a new line in here? Why doesn't the new line show up?
Is the a.out just for that first instance? So it creates another
Exactly.
instance every time you make a change?
Exactly.
To hello.c?
Exactly. So just like if somebody changes the Spanish version of Don Quixote, somebody's already translated it, right? We already have the translated changed version that's in English. So if they make a change to the Spanish version, the translator has to go in, find that change, make the change in the English version. So I need to recompile this program. So I'm just going to run my compiler again, just hit the up arrow a couple times. And now it's recompiled it. And now when I run a.out, I get the hello world. Okay. Question so far?
So real quick, do you have to recompile your files every time you make a change?
Yes.
Okay.
Yes.
And then that a.out, sorry, I'm not really picking up on that. What exactly does that represent again?
The a.out. So if I try to look at it, it's, let's see if I open it anyway, what it's going to show me. Whatever. It's this. It's the gibberish that the computer understands, right? So this is all just like translated into something that a computer can actually execute. Like the computer doesn't understand the word print or printf. It doesn't understand main, right? It's going to take this and it's going to convert it into instructions that a computer understands, right? So when I get my a.out, I get this, that the computer just sort of knows what to do. Okay.
Okay.
Does that make sense?
Yeah, so is that /n kind of I don't know, modifying the string so it can be interpreted in the a.
So the /n, that just, all that did was add a new line. It just put my, because when I first ran it, see how my right here, the hello world was on the same line as my next.
Mhm.
So I put that /n in there so it looked better like this.
Okay,
Okay.
thanks.
Any other questions? Okay, so again, my point is we're not going to learn C. I promise. This is the only time you'll see C code. But I wanted to do this to sort of show you this is where Java gets its syntax, and this is why we do the things we do, because C is like the Latin of programming languages, right? So if you want to get better at other programming languages, I suggest you learn C. Don't do it right now, but C is a great language to learn because it will help you understand why things are happening in other programming languages. So if I come back in here and I'm going to write the Hello World program in Java this time. And did I already do it? Nope, I want to do it there. So I'm going to make a new file. And I'm going to call my file, I'm going to give it a special name. So I'm going to capitalize the name of my file. So it's going to be hello. And then I add the .java extension. Okay, and that will create a Java file. Now notice that as soon as I hit enter, I have the extensions installed in Visual Studio Code that will help me out with my Java language. So what you name the file has to match the name of the class. Okay, so everything in Java is a class. Java is very object oriented, right? So you can't have anything, you can't have a file that isn't a class in Java, okay? So inside the class, again, just like we had in C, we have to have a main method. We have to have a starting point where the compiler knows to look and say, okay, this is the function I need to run to get the code to run. So in Java, it's public, and I'll talk about what these words mean in a second or in a little bit. Public static void, and I can't remember if it's capitalized or not. I think main. Okay, so that is the equivalent of the main function in C, right? So it's a little bit more verbose, a little bit more wordy, but you'll see that this is the sort of inspiration for the main in C. So main here in C, main Java has the same thing. Now, if you can't remember this, which I couldn't remember, I still can't remember if it's capitalized or not. If you have the extensions for Java installed, you just have to remember that it's public static void main or PSVM, and it will auto complete it for you. It'll fill it in. So you don't have to remember all the syntax, right? And then if I want to print something to the screen, it's system.out.println. Okay. And then never forget the semicolon. Okay. Now, Java, like C, is a compiled language. So we have to compile this code into bytecode, into something that the computer understands. So in order to compile this, I need to do something like what I did with the C file. So in Java, it's going to be Java C and then the name of the file. Okay. So Java C, that stands for compiler. So if I hit enter, no news is good news. If I look at my file structure, oops, I have the hello.class. That's the equivalent of my a.out in C. So this is the bytecode and bytecode's a little different than what C produces, but it's basically what the JVM needs in order to be able to run my code. Okay, so now if I want to execute this, it's Java and then hello without the extension, and I get hello world. Okay. Make sense? Questions? Okay. Let me do this. I don't know if I have my polls set up. in chat, put a, oh man, hold on. Yeah, put if so, give me a rating on the scale of 1 to 10. 10 means you're completely understanding me, you're totally with me, and 1 means you're totally lost. Good. 9's sweet. Nice. 10's. Cool. Awesome. All right. So the reason I did this in Linux is because I want to show you the difference between and why Java is cool, right? So why Java is what it is, why it's become such a popular programming language. So I'm going to come in here to my version control, and I'm going to save all this stuff that I just wrote to my repository. So I'm going to call it demo C Java. I don't know if I can have the slash in there. Demo C and Java. So I'm going to save everything, commit, sync. Okay, I'm going to stop sharing on Linux. And I'm going to go back and share on Windows. Okay. So this is the same repository. So I'm going to just come in here. I'm going to throw this away because I don't think we need it. You guys all know how to write Python code, I think. So I'm going to pull from my repository. And notice here's all the code that I wrote on my Linux machine. Okay. So I'm back on Windows just to prove to you. Let's, if I can prove to you, that's Windows, right? So I'm going to come in here and I'm going to, I have the same executable file that I wrote on Linux here in Windows. So I'm going to say Java, oops, switch my, Java hello, not run the C file, and I get hello world. Okay, so I wrote this code on a completely different operating system, completely different architecture, and the code that I wrote on Linux works just fine on Windows, which that should be amazing, right? Because if I run my hello.c, if I try to do a.out, I get has no idea what I'm talking about, because I would need to recompile that code that I wrote on Linux. I'd have to compile it in a C compiler for Windows. If I wanted to run on Windows, I'd have to compile it in a C compiler for Mac if I wanted to run it on Mac. The cool thing about Java is there's an intermediate between the Java code and what actually gets run on my machine, which is the JVM, okay, which we'll talk about in a second. Okay? Make sense? Everybody with me? Cool, cool. All right. Oh, I saw something in the chat. Oh, just numbers. Okay, cool. All right. Let's see. By the way, normally we're going to do algos first thing in the morning. On the first day, I postpone algos until the afternoon, and we're going to do algos. Just today, we're going to do algos in Java, just so we can get more practice with writing Java code. Okay. All right. Oh, I didn't stop.